everyone. Welcome to week 6 of RPS at Home for 8th grade physical science. My name is Mrs. McPhillips and I teach physical science at Albert Hill Middle School. This week we are in our third week of the unit on electricity and magnetism. Last week we were studying the relationship between electricity and magnetism. This week we are going to drop magnetism and kind of focus a little bit more on electricity. The topic is conductors, insulators, and semiconductors, as you can see here. So to start out today, we do want to make sure that you know how to get to the RPS at Home resources. If you're watching this video, odds are you already know, but as a reminder, you can go to rvaschools.net, click on the RPS at Home button right here, and then you can access the middle school resources, click on 8th grade, and then you'll get to the calendar, which will give you all the lessons for all of your classes. So for this week, week 6, that is May 11th through 15th, we're doing conductors, insulators, and semiconductors. First thing you'll need to have open is your learning plan for this week, which looks like this. You can see we've got 3 days of instruction. The first day, today, we're just going to kind of dip our feet in with conductors and insulators. The first step is to open up your student workbook, which when you click on this link will send you to this document. Please note that in order to work on this document, you have to click File, Make a Copy. And then you can rename it with your name and it will be saved in your Google Drive account. It will not let you type in it unless you make your own copy. It might even ask you to request for access, but you don't need to do that. Just click File, Make a Copy, and then you can type in it as you wish. Or if you prefer to print it out and write on it, that's just fine too. So for our workbook, the first thing we're going to do today is watch 3 videos. And as we have been doing, we're looking for 3 things when we watch the video. One is just, what do you see? What is actually happening in the video? The second is, what do you think is going on? Maybe some kind of explanation for what you're seeing. And the third thing is, what does the video make you wonder? Do you have any questions after what you've watched? So we have 3 videos today. All have to do with conductors and insulators. The first one is called Paper Circuit. The video is a little long, so I'm going to start at about 23 seconds and I'm going to end at about 2 minutes. But on your own time, I would encourage you to click on the link and watch the whole 4 or 5 minute video because there are some interesting things that he does afterwards. But let's just watch the first little bit of it together.
By using basic drawing materials such as a graphite block or a pencil, we're going to be able to draw a circuit out on a piece of paper, hook a battery up to it, and actually power an LED light. In the early 90s, Forrest Mims unleashed several cool experiments on the world in his book called Science Projects. This first example was included. If we draw out a nice thick line on some paper, the graphite in the pencil will actually work as a resistor. And as you may or may not know, a resistor basically restricts the flow of electrical current. Graphite itself is a pretty terrible conductor of electricity, but it will carry just enough to light up an LED when the source is a 9-volt battery. Now, an LED typically requires 3.5 volts to power up, and going too far above that could nuke the light itself. Due to the resistive properties in the graphite, we're actually able to cut that power flow down to a more reasonable amount, which will power the LED safely. You'll also notice that the LED gets brighter and darker depending on how close we get to it. That's because we've actually created a variable resistor. But what if we wanted to make an actual circuit out of this? Would the resistive properties prove to be too great, or could we still transfer enough energy to light and power it up? So let's give it a try and find out. After doodling a little pencil maze, I poked the LED into a positive and negative terminals. I lowered the lights, and as you can see, it powered right up. Obviously, some minor adjustments were needed to get everything to sit right, but the result was a paper circuit.
And again, I would encourage you to keep watching that on your own time, but we'll stop there for now. So in your workbook, please write down one thing that you saw in the video, one thing that you think is going on, and then one thing that you wonder. The second video for this week is called Orange Fruit Batteries Power an iPhone. And for our third video today, after you've recorded See, Think, and Wonder for video 2, we'll watch the third video, which is metallic balloons versus power lines.
Now, a metallic balloon, of course, is conductive, just like an overhead conductor. Our conductors are insulated by air, and they're insulated by the distance between the conductors. But when you put something that is metallic across those conductors, what typically happens is an arc flash. So now, will you energize that line?
Energized.
We are hot now.
Okay, hot.
What I've done is I've created a short circuit across the conductors. It's the same type of short circuit that you'll actually see on a power line. And in addition,
Whoa! That's pretty.
wow.
Good job, balloon people!
I don't know. I almost thought that one.
Okay.
All right, so those are our 3 videos. All 3 are actually showing a property of electricity, an example of electricity known as a conductor, which is what we're going to learn about for the rest of the week. But for now, no need to worry about that too much. Just write down one thing you see, one thing you think, and one thing you wonder in the table. After you have finished that, we will move on to our next step, which is a Phet simulation. You know, I love these even when we are together in class, and we can actually do experiments. But because a lot of the experiments for this particular topic require you to have batteries, wires, light bulbs, battery holders, light bulb holders, all these things that you're not likely to have in your house. I don't have them in my house, and I'm a science teacher. There are some very good online simulations that will basically do everything that we would do in class. It's just going to be like virtual and digital. So I really like this one. You've seen it before because we used it in, I think 2 weeks ago, we used this one. So you'll click on the Phet simulation and you'll see that there are 2 tabs that pop up. You can experiment around with both, but all we really need to use is the intro tab. So I'm going to click intro, and then you get a screen that looks like this. So right now it's blank. I just want to show you some of the functionality of the simulation, and then I'm going to let you play around with it. Your menu is over here on the left. You can scroll up and down, and you see you've got a lot of different items for you to use. The most basic items are at the top. So, you know, you got a wire, a battery, resistors, which you may not have heard of before, a switch. Once you place an item, you connect it at these like dotted circles, and then you can actually click the other end to rotate. You can stretch it around. If you would like to delete an element, you just tap on it and then click this little trash can icon. So you can delete items if you don't want them anymore. And remember that in order to connect them, you have to overlap the circles. So there's a lot of different tools on here. You can even click to show the current, either with the electrons, which are these little blue circles with negative symbols in them, or conventional arrows. In order for you to actually see the electrons moving, you have to build a closed circuit. So since we already did circuits, I'm just going to cover that with you now. Here's an example of a simple circuit. It's got a power source. I'll hook up a light bulb and a wire on the other side. And you know what? Let's just go ahead and connect that wire here. Boom, the light bulb lights up because this is a closed circuit. You can see the electrons are moving. They're moving away from the negative terminal of the battery through the light bulb, through the filament of the bulb, causing the light bulb to light up, and then back into the battery. If you click conventional, you can see the direction of the electrical current, which is actually opposite the movement of the electrons. I know it's kind of weird. So that's how to do it with just a plain simple circuit. But what we're going to test today, if you see in your workbook, I want you to build a simple circuit that looks like this. We're going to make it an open circuit. So you can see in this picture, I've got a gap between the bulb and the wire. So this is not actually going to end up working. But let's go ahead and build that. So in order to do that, I'm going to delete this section of wire, and maybe I'll add one more section here. So we have an open circuit. Our task is going to see what kinds of materials can we put in the middle of the circuit and still get the light bulb to light. So for instance, I'm going to go here to my menu. The first item that pops up is a dollar bill. So let's try putting a dollar bill in the circuit. It's connected there and there. And you can clearly see the light bulb is not lit up. Even if you wanted to use the voltmeter, you could be able to see here that there is no electricity flowing. And I'm going to try to move that out. There's electricity flowing across the battery, but there's no electricity flowing like in the bulb or anything like that. So, and clearly the light bulb is not lit up, so that one doesn't work. Then we can delete our dollar bill, and we can try with the paper clip. And you can see pretty quickly that yes, the paper clip does work in the circuit. And we can see that there's a voltage of 9 volts going across the whole circuit. So there is electricity flowing when the paper clip is there. You've got these other items to test too, a coin, eraser, pencil, hand, and dog that you can test. If you would like, you can even try adding more than one bulb or adding more than one battery and see what kinds of effects that you get. I encourage you just to play around with this. You do have some questions to answer here. You've got the data table where you're going to record your observations. The observations are basically, can you get the light bulb to light up when you put that item in the circuit? And then 4 questions after that. So once you've done that, that pretty much finishes up today's work unless you have the materials at home to build your own circuit. And if you do, I would really encourage you to give it a try. We've got an optional hands-on activity for today, which is a conductors and insulators lab. It's important to note that the materials required are listed here. You need a small light bulb, like the one that's in a small flashlight. 1.2 volts is ideal. You could use a light bulb base, which looks like this picture. It's just like a socket for you to screw the light bulb into. But if you don't have one, you should just be able to use electrical tape to tape the wires to the light bulb base itself. You need a D battery, and you need some insulated wire. Insulated wire means the kind that has like the rubber casing around it. You will also need to strip the insulation off the ends of the wire, leaving about like 2 centimeters of space of exposed, preferably copper wire. So you'll need a wire stripper to do that and some adult assistance. Again, if you don't have these materials, it is okay. I know these are materials you might not normally have at home, but I did want to include this here just in case you were able to do it. There is a link to the full instructions that looks like this, and it has the same picture that I included there. So I hope that you are able to give that a try, but again, if not, no worries. But I will see you back here in a couple of days to do the next lesson on conductors and insulators.